After a wonderful session on Android boot time optimizations, I'm taking everyone back to the world of RTOS. So this is like completely a other side of the world and dealing with MCUs and dealing
But it's
with...
really fast. So
Sorry?
Your boot time is really good as well.
And it's a completely new and different world for us. And then starting with Zephyr, there it's like a completely new approach and dimension. So I actually wanted to bring a different problem here to discuss, and then this is mainly towards MCUs and Zephyr. But then I was telling to Karim this morning, Android is being replaced by Zephyr in many IoT and embedded applications, even Linux in many places. So most of the concepts that we are discussing on boot time, on many things else like the low latency and such things are moving to Zephyr. And Zephyr coming from as a flavor of Linux, the adaptability is much higher. So let me quickly get into the slide. So I don't want to introduce TI, but I want to introduce a few things like where we are enabling Zephyr. So we are enabling Zephyr on processors, and which is like ARM A cores and ARM R5 cores, or it is your M4 cores and such things, and then application-specific microcontrollers and general purpose microcontrollers, and the drivers for connectivity like Wi-Fi, Bluetooth, and such things. So Zephyr is running on all these places today. The scope of this presentation, as I said, like I want to bring and discuss a different set of problems here, which is mainly involving Zephyr and RTOS. And the focus here is to see like how we can enable Zephyr and compare it with any kind of bare metal RTOS or bare metal device drivers that we regularly develop on free RTOS. So let me go more deep into this and then come back to the actual problem. So where all do we use RTOS today, and what kind of RTOS do we use? Now, if I want to just give a very high level overview, in any kind of time critical applications, safety driven applications, low power applications, secure, connected, and which needs quick boot time and very easy to use. So in these areas today, we are using some kind of RTOS, right? And this RTOS, as I just said, it is not just running on microcontrollers, but it also runs on very high-end ARM Cortex A core, which is almost running at 1.4 gigahertz kind of thing. So it's not just a play of few megahertz kind of microcontrollers, but it is also running at gigahertz family of microcontrollers and microprocessors. RTOS also runs as a add-on module to A core, like you have in a system. If you have ARM Cortex A core and then you have some MCUs, then RTOS is running on those MCUs as well, right? So Zephyr runs, so when you think of Zephyr, you shouldn't just think that Zephyr is actually running on a simple IoT standalone device, but you should also think like Zephyr is running on a microcontroller, or it is running on as an operating system, as a scheduler. It is running on a MCU core or an add-on module or an accelerator. It could be anything, not just a bare metal basic fundamental kind of device. Okay, so what is the traditional practice that any RTOS engineer or RTOS end equipment is following today? Like the stack goes from bottom to up. So developing bare metal drivers is first thing an RTOS engineer does, or an RTOS end equipment starts with, right? Simple C file, simple include file, and then you have some compiler and you just finish your microcontroller coding, right? And then when you think like you need a scheduler, because now I want to get into a multi-threaded environment and my application becomes multi-threaded, then you start applying a free RTOS or a ThreadX kind of simple RTOS as an add-on to my bare metal application, which I just wrote, right? When you think of like, okay, now I have added an RTOS and I have a bare metal driver, but it is a networking device, or it is a flash, or it is a file system based device or something, then I go shop for open source frameworks or commercial frameworks, like it can be your TCP/IP stack, it can be your file system stack or USB stack, connectivity stack, Bluetooth stack, and such things. So you bring that kind of framework on top of it. So as you can see here, right, the complexity is growing from just a bare metal C code to making it like a productized end equipment, right? And as you go up into the stack, you will start seeing commercial operating systems, commercial real-time operating system, which I have given as an example there, right? So the bare metal driver to a productized thing, if you see, the foundational piece here is still the bare metal C code that I wrote. Okay, I'm not changing the framework, I'm not changing the real bare metal code here. This is how a traditional RTOS engineer or equipments which are dealing with RTOS or in real-time operating systems are dealing with. Now, when it comes to Zephyr, now what industry has done in last decade is they are treating Zephyr as any other operating system. The way I just mentioned or described, start with bare metal code and then stitch it into Zephyr with a very thin shim layer or a HAL layer. Now, with this, what happens is like you are losing the entire benefits of what actually Zephyr is offering as an open source, real-time operating system with all the benefits of Linux and Linux community, ecosystem, environment, everything. Like I don't want to get into describing the benefits of Zephyr as an open source RTOS, but what I want to highlight here is the approach that RTOS community has been following or engineering community has been following in dealing with FreeRTOS or ThreadX and such kind of real-time operating system. They are applying same terminologies or same flow to deal with Zephyr, which in my opinion is, I won't say fully wrong because I do the same in TI as well, but then that is not the right approach. I don't want them to go to the route of taking the RTOS approach into Zephyr, because Zephyr has a lot more for any open source framework to offer, right? Like you have plenty of things as has device tree blobs or the West report tool itself or your frameworks that Zephyr is offering. There are plenty of benefits and easiness of things which are getting lost by following the traditional RTOS application development. Now, what industry has done is they have taken this bare metal code, added a shim layer, wrote a simple vendor HAL, and sticked into Zephyr and thinking my job with Zephyr is done, right? But then with that, what has happened is tons and tons of code has come into Zephyr on a separate parallel repository, which is like your vendor HAL repository, and it is staying there, which only the SoC vendor or silicon provider or if it is a chipset, if it is a chipset, then the chipset drivers are sitting in a separate repository. It's actually not truly integrated into Zephyr, not reviewed by the open source community, not following the standard practices of any open source community. It is staying completely outside of the Zephyr world, right? Now, this should not have been the case. We should have really written native drivers for Zephyr. That's what I'm getting towards. Now, the challenge that we have is once we start writing native drivers for Zephyr, the thing that industry has, the challenges that industry has will not go away, right? Now, how do we stitch or balance between these two layers? Like why I mean industry is not going to accept this approach is because there are tons and tons of investments which has already happened in these RTOS operating systems, right? Like there are commercial operating systems, there are free real-time operating systems which are available in the open source world, and there is a lot of certification that goes here which these operating systems are giving. Now, the bare metal driver that I wrote can stick into any of these operating systems, right? Now, therefore, I need to find a way, if I enforce my engineers and the community to build and develop Zephyr drivers in the native Zephyr way of doing things, then I also have to show a path to them to how to take this bare metal driver and stitch into any of these traditional operating system. So the problem here is always, or in the last 1 decade, the industry has followed the other side of approach where they wrote the bare metal driver, considered Zephyr as another operating system, another real-time operating system, hooked that bare metal driver on a separate repository, calling vendor HAL, wrote a shim layer, and somehow fixed the Zephyr requirement, right? Now, how do we do it in a different way? Flip it. Start with Zephyr first, right? Write your bare metal driver in such a way that it starts with Zephyr, gets reviewed by the open source community, gets an ACK from open source maintainers and community that has its own value, right? And I will not get into that. Once you do that, then if you want to go for a safety certified operating system, or if you want to go for any vendor specific operating system, right? Okay, now you take this driver and put it in your other operating system. There is a path. And if we teach this path to the RTOS engineers, then definitely we can see more and more RTOS engineers joining the Zephyr community. And if you show the path how you can migrate those Zephyr drivers to the other operating system, then it becomes like, first thing, we are getting more community on Zephyr side. Second, we are also using the best of the other world, right?
So let me play devil's advocate here.
Yeah.
So why Zephyr first? Why not do it in ThreadX first and then export the bare metal driver from there and then do it in Zephyr? So, I mean, don't get me wrong, I like the approach, but it's more like, what makes it so beneficial to do it in Zephyr first and then do the export from there?
Yeah, today by doing in Zephyr first, by not adopting to Zephyr first, like as I was just highlighting, the code is not coming into Zephyr first. The code is coming into a separate folder and separate repo with vendor HAL. Like when I am including TI, any other organization, if you download Zephyr today, it is coming in 2 repositories. One, our Zephyr project, and then second, HAL project, right? You have to download these 2 projects, then it forms Zephyr source for compilation. Now, as I said, there is code which is directly coming in that HAL repositories, which has zero control from open source community, because the repositories are owned by the organizations which are pumping in the code, and it is not following any framework, it is not following any standard practices, coding guidelines, nothing, right? It is some code which was written for some other operating system is making its way into Zephyr, right? Now, how do you bring that kind of framework? How do you bring the open source beauty into Zephyr for RTOS world? There are so many benefits of Zephyr which are not getting consumed.
Basically, the biggest benefit for this flipping around, you see, it's more like that you have like the open source practices of like doing the peer review, making sure that you have like come to a point where the code is actually acceptable by most people,
yep.
And then from there doing the export. So that is, you want to use Zephyr for its community of reviewing and so on to get the practices in.
I can go more like the CI/CD. The tooling that it has, like the West tooling, which no other operating system offers, right? The Twister, the tool that we have for testing, right? There are so many things that Zephyr offers which RTOS community can use. They are not getting onto Zephyr first approach because they have a lot of their code written for some other operating system and then bringing in and trying to checkmark Zephyr, saying like, yeah, we also have Zephyr operating system offering, and not making that as a true Zephyr development.
Okay, maybe we come to that later, but how would you make sure that at some point you're exporting that? And let's say you want it for some certification stuff, you want ThreadX or something, just an example, right? How do you make sure that this is getting updated as well? Because if you do this approach, your developers would work with Zephyr all the time, make sure everything gets supported, new boards getting added, bugs getting fixed, and so on, right? So there's a constant flow of like changes and releases coming out. How do you make sure that this is all going into the bare metal version and then flowing to the next to the different consumer, basically, in a different one.
Yeah, I have listed down some of the things that when you start writing Zephyr driver, how you can structure it in such a way that it can become an easy migration. So I have some steps which I have highlighted here, which I'll describe.
Just wait.
Yeah. So hope, yeah.
Go ahead. Yeah, okay, but if you structure the driver in some specific way, is it still compatible with Zephyr, or is it some sort of a
no hack way,
HAL-based hybrid which doesn't really fit into Zephyr?
Yeah, it shouldn't be. That's the whole point. Like from my team and me, we have formed a skeleton with which, if we follow, we adhere to the best of both worlds. But then we need to improvise it, and there is no strict standard way that we are following today. But if we can come up with a common practice, so today Zephyr has not taken this requirement that the driver that I am going to write can be easily deployable in other operating systems, right? That has not been a requirement. If we can consider that requirement, put some standard framework around it, then it can be easy for us to migrate.
There's one more question on where you want to be, so please, well...
You can do the in-room and then I'll ask mine.
Voice again.
This one?
Goran, could you...
Can you hear me?
Yes, we can.
Yeah, okay. Yeah, my question is the idea of the Zephyr, using the Zephyr drivers as a bare metal one is similar like some industry practice, such as the AutoSAR CP. In the AutoSAR CP specification, there have M-core specification that separated the driver layer outside the scope of the entire OS. So, how to practice your idea? I mean, do we need to define a Zephyr M-core similar specification to separate the drivers out of the Zephyr code base?
Correct. Good question. I have a slide to talk about it. Give me 1 minute.
Yeah,
I'll get there.
I'll go next. By the way, this seems very similar to the same issues we had when Android was coming out.
Sorry, I lost connection, right?
Go, he said he'll get to your question in the subsequent
Khasim
slide.
will talk about the AutoSAR setup in a minute, so he has a slide about that. So let's wait for Sarvana's question, and then he can follow up with the next slide, so we can move on.
Khasim, just a quick observation. All the problems you're listing so far seem very similar to when Android was coming up and people were starting to use Linux from the SOC vendors. So, couple of questions. One of the issues like SOC vendors have been always complaining about is like, hey, if you go to the open source community and review, it's going to take time before we can get our stuff done. Whether we agree that's valid or not, that's the mindset they have. Is that something you're not seeing here, or is that like, I feel like that's the biggest problem that needs to be solved, more so than these things, right? Because to do Zephyr first they need to agree to do upstream first. Do you think that's not an issue of the Zephyr community?
No, that is a very good observation that you have, and that is one of the the mindset or challenge that this RTOS community feels, because they're not so used to this kind of upstream culture where they submit the code, wait for the response, see the response and fix it, and then absorb it into their internal SDK offering and such things, right? So definitely there is some kind of hindrance there in accepting this approach, but somewhere or the other we need to start experiencing that and bring that methodologies of open source best practices into RTOS world, right? Definitely that is one of the key challenges that we will be having when we enforce this methodology.
Yeah, because what we used to see before was that they'll all be Windows mobile-based drivers with HALs, and then they'll kind of wrap it into a Linux driver, try to ship it early on an Android devices.
Agree.
And as Android became more popular and died out, Linux became those drivers became Linux first.
Yeah.
So it almost feels like it's going to just go where the market is going, but we can hope things are
No,
better this
agree.
time.
I agree there. So few steps that we have identified, I can list those things, but these are not only the steps that are sufficient to make an RTOS development on Zephyr first. So few things that I can quickly highlight here in interest of time. First thing, like if you see any Zephyr driver here, it has three major components. One is how it is dealing with the clock framework and the device tree and the kconfig approach that it gets into, and then the device operate like the DevOps structure itself of Zephyr. So if I am an RTOS engineer who is starting my driver development with Zephyr first, then I would have written the Zephyr driver in this order, right? I would have used the clock framework, I would have used the device tree, I would have done all the configuration using kconfig structure, and I would have used the DevOps main device driver structure to fill all the configuration parameters. Now, when I have developed this driver, now how is it easy for me to take this driver and fit it into a FreeRTOS or ThreadX environment, right? Now that becomes a challenge. So here is where we are thinking how we can detach. So first of all, how do we develop the driver and in such a way that it becomes so easy for us to detach it from Zephyr and put it into any other operating system, right? So for all this, if you see all the previous presentations on Zephyr, it has always been told or taught to the community how to bring in RTOS drivers from FreeRTOS and ThreadX and stitch it into Zephyr. But this is first time I'm trying to say, like, if you have started your development on Zephyr, then don't worry, there is a path to take from Zephyr and put it into other operating systems as well, right? That's how, that's the difference here. So first thing, the way we are trying to do here is, like, as much as possible, the device tree. So first thing is Zephyr completely depends on DT concept, right? Like you do all your configuration parameters, setting of all your fundamental IOs and things in DT. Now, how do you take this DT changes into an RTOS driver, right? It's very easy when you start with Zephyr, because Zephyr gives you build time script which can convert your DT into a simple include file. So that gives you all the macros that gets listed, right? That is the first fundamental thing that anybody can do, to just run the Python script, you get your include file. That include file can go into any of the traditionally available RTOS operating systems. Second thing, when we are writing our Zephyr driver, write it in such a way that there is a very clear differentiation between what gets hooked to Zephyr. Keep that as your high-level driver, and whatever you want to carry into different operating systems, make as your low-level driver. There are definitely a lot of examples in Zephyr itself today which shows how to write a low-level driver. Follow those. This is very easy way of dealing with when you are migrating or porting Zephyr drivers into other operating systems. The other fundamental challenge that we get into is like usage of sleep, right? Like Zephyr has different types of sleeps, like use sleep and K-sleep timer, and there are so many different APIs that Zephyr offers to sleep in a function, right? Now, when you move that now I have written in application or a driver, and I'm moving this driver as is into another RTOS. Now that sleep function has to be properly dealt with. You might be thinking that you gave 100 millisecond and Zephyr might be dealing with that 100 millisecond in a different way. Now, when you take it into another operating system, you may not be able to measure that microsecond or millisecond latency, and that might make your equipment malfunction, right? We have to be very careful here. There are ways to deal with timers. This is one area that we can look into. And definitely there are various Linux best practices to follow for making your driver portable. Like any RTOS driver developer uses direct address mapping and things. So use structure definition so that you can when you are moving your code from Zephyr to another operating system, let the sections of your code where you are accessing the registers and memory area are very well segregated and defined so that you can easily migrate them. So I have given few examples here. I will not go into detail. And keep the portable pattern and non-portable pattern separate. That's what it means. And then clock and power, right? This is very important because Zephyr comes with very good clock and power framework. This is very, very important when you take it into any low power application. Zephyr is giving you all the framework to take, to build an end equipment which is low power, but you will not find similar frameworks and hooks in any other operating systems because they are not so power aware devices, okay? So when you move this clock framework into another place, you may not be able to easily move because there is no such clock framework existing in any other operating systems. So how do you manage that, right? There are few examples which I have shown here in the Git repository. But keep your code clock agnostic, right? That's what it means. So don't have static states defined in your DT, but you have to follow on one end the Zephyr clock framework, but keep your clock architecture in such a way that you can easily move into FreeRTOS world or any other operating system world. I will not go detailed into this because I'm losing time here. The other important part here is the ISR context, right? So in any sample driver that you take, there is one read function, write function, and there is an ISR, right? The ISR that handles all your interrupt thing has to be very, very low latency thing that you write. So make ISR very OS agnostic so that you can simply copy that ISR into any other operating system. Again, there are some good examples of these in existing Zephyr stack. The other part, when I write my Zephyr native driver, is I would have followed this device structure that I am showing here on the screen. Now, as I said, right, the clock framework that comes with the PM device structure and other things that you are seeing here on the config, the dev stats and DevOps, all these structures would have been filled to keep some state of the driver, right? Now, when you move these things into any other operating system, you will find it difficult to move the structure as is. So this is one area which we need to discuss and deal. So 3 to 4 topics, I don't have very straight answers. As you might have seen me jittering when I'm talking, one is the clock framework, and second thing is the DevOps structure. These two things we need to understand how we can make it modular such a way that these drivers can be easily portable to another operating system, right? So I was saying all the benefits of Zephyr first, like you get CI/CD, you get Twister, you get robust framework. Like as I'm saying, right, like we start with RTOS bare metal driver and then we go into any kind of an end equipment, but then there is a very big vacuum in frameworks, whether it is TCP/IP framework or it is your file system frameworks, USB, Bluetooth, connectivity, WLAN, and these kind of things, right? There are a lot of gaps if you take any other real-time operating systems, but in Zephyr you have all these things solved, and it is getting continuously invested and evolving, right? These stacks are getting matured. Now, we can definitely leverage these stacks for other RTOS applications. And when you go into SBOM generation, CVE, CRA, and such things, Zephyr gives you a better hold on end equipment from safety point of view and CRA point of view. Now, these things can easily be easily leveraged for RTOS-based end equipments as well. And so definitely a lot of value add on Zephyr. Start your driver development by doing Zephyr first for RTOS engineers. Take those drivers easily and port it into any other operating system. So that should be the practice, and we are actually moving to that mindset in TI now. And earlier, like if you see, we have a lot of projects in Zephyr today from TI, which is following the regular approach where we have written the code for FreeRTOS world, and we brought that code into Zephyr over a HAL and shim layer. But now we want to go do Zephyr native drivers first. And while I'm doing that, I also want to make sure like I have a path to move the driver to any other operating system, whether it is commercial RTOS or non-commercial RTOS. But I also want to keep my involvement in community, get the best things out of open source reviews and maintenance of the code for long term, handling of CVE, CRA, and these things. Okay, so this is all ahead, and hope I have given some problem here and I have not solved everything here, but I have elaboratedly discussed the problem here, right? Open for questions.
Okay, I have a, so first I want to just say I do agree with the Zephyr first, and I'm not familiar, I'm not a user of Zephyr on there, or I'm a contributor to that. But part of, like with Linux and the OS provides is the framework, like for the different drivers. And that's why like we as a community at Linux on average have smaller drivers than a lot of other operating systems because of all these frameworks that we have in the kernel. So when you see like common patterns, that's when you can add it to the framework. But if they're with this approach, and I do see value in that, but also they might be writing it to the lowest common denominator, in that maybe there might be some framework in Zephyr that's there, but maybe some other RTOS doesn't have it. So then they can't write the driver like that because of that.
Correct.
It's not really a question, it's just a comment on, because sometimes there isn't an advantage to, if you make it just Zephyr specific, you can use the Zephyr frameworks and everything else there, but then you don't get the reuse in the different platforms.
Correct.
So I don't know if you have a comment on that, or...
Fundamental thing is, like, I don't want to comment here because I want to move from all other operating, like I showed you the list of RTOS that I need to deal with, right? Like I want to move out of all those supporting 10 RTOS into one Zephyr RTOS, right? I want to move from all the traditional operating systems to a Zephyr-based RTOS operating system. But then these are the challenges that I just highlighted, right? Like I have all the investments made, now moving all those drivers into Zephyr native driver is very difficult for me. So I am carrying my HAL in a separate repo and managing that for Zephyr. But then I am not teaching the community or RTOS community to write a driver which is very open source friendly, right? That is the big mistake that we are doing here. And a lot of unvalidated code is getting into those vendor specific repositories, which we need to fix it, right?
Discussion over there. Just a quick reminder, so we are in the break right now. That is not a problem. We can keep going here. But if you leave, just be a bit silent so you don't disturb others, but we can keep going here with questions.
So in an effort to make things agnostic, presumably you're not using Zephyr work queues for threading and scheduling, right? So what did you guys do to, like, did you guys make your own thread scheduling or something else bespoke for that? Or how did you solve that sort of problem if you're, say, like, you know, your software was relying on work queues, like what did you do instead? Yeah,
we haven't solved that problem yet. That is one problem that we need to solve when we moved the driver from Zephyr into another RTOS. So today we are dealing, two ways to split this. One, like if I have written an application on Zephyr, right? If the application on Zephyr is following CMSIS standard, then you can easily move that driver to any other operating system if you are following similar standard. That is on the application space migration. Like you have an application written on FreeRTOS, you can move to Zephyr. That's one part, right? What we are dealing with is the driver layer, which is the lowest layer. Now, where is my diagram? Yeah, like we are not talking on applications and frameworks, not touching the OS hooks, but then dealing with only the driver portion of porting or migration or that part. But there are challenges there. I agree or understand what you are trying to say, but we haven't solved usage of work queues in other operating system.
Okay, cool. Thank you.
I had a question.
There we go.
Yeah.
Zephyr, have you considered the other direction where if you, another way to entice is, hey, if you write a Zephyr driver, you can convert it easily to a Linux driver. Is that something that's realistic or is it true? Will that give any incentive to commercial entities to consider that as a reason to do Zephyr first? And with the AI being all the buzz, is it easy to have AI convert a Zephyr driver into a Linux compatible driver?
Possible. See, for AI conversion, you need to have a framework first, right? Fixed framework first. Today, by every vendor is following their own methodologies. Therefore, you can't easily have an AI agent to convert a given driver into a Linux driver, right? If continuing to use Zephyr, it becomes more and more standardized, and then definitely there can be a way to convert a Zephyr driver into a Linux driver. It is possible. But through AI, definitely it is possible. And if we have a standard methodology to write any driver, I am adding an PWM driver or GPIO driver or a flash subsystem driver or a network connectivity driver. If I have a traditional structure or a standard structure and standard methodology, standard APIs, functions, and system calls, definitely it is very easy to port to Linux.
I mean, that is the crux of it, right? Because if you have everything standardized and so on, we don't have the flexibility we have in Linux right now, which I think most of the developers are actually enjoying and using. Brian was touching on that with the frameworks, right? So we identify problems across the board. We find ways to optimize that, like layers of code a bit differently and so on. And we are not able to do that if we rely on standardization. I understand that because, I mean, I've seen enough kernel abstraction layers and so on in my time to understand it is very interesting to on a vendor perspective to make one driver beat, in this case, Zephyr first and then export it over. But in the end, I mean, as I said before, I'm happy to see that going on, but I think only the time will prove if there's really something reliable others will actually can use and so on. And for me, it's not so much on the technology challenges you have here, it's more like how they're really adopting that over time. But I mean, that is future looking, I don't know about that.
Yeah.
Just a comment.
No, I think we will have more examples by next year. As I said, we are starting that approach, we are on that path. More and more we unveil these kind of problems, then we will have some more data to share with the community.
I had one last question. That's it. If a vendor is able to get a certification on one RTOS, are they able to take that same driver and port it over to a different RTOS and keep that same certification?
No.
Okay.
They cannot keep the certification, but the advantage that you will get is once you get your driver, you will run some checks and tools like clockworks, you will do dynamic analysis, static analysis of the code coverage, and such things you would have done. Now, if you have written the driver in such a way, then if you migrate to another operating system, your code snippet would still carry all the fixes, right? Then when you apply for certification, definitely you will get advantage, but you will have to go for recertification anyways. But the effort would be minimal or zero.
So Jan, last question from you, and then I think we close it down for a break.
I was wondering if you have any license issues because of the Apache 2 license of Zephyr and other licenses in other operating systems.
For TI, at least I analyzed this. This was one of the key topics that I initially analyzed before giving this presentation itself. For BSD, right, we are carrying a lot of code on BSD. We are also carrying a lot of code from Apache in our SDKs. As I showed in my first diagram, though we wrote only bare metal code, but when we were bringing the frameworks, for example, if we bring in LWIP or we bring in a lot of these open source RTOS frameworks, they're all coming with different licenses, right? In the RTOS world today, we are already carrying multiple licenses to fix one problem or build one end equipment. So by taking this Apache code into any other free RTOS stack, or when I say free RTOS, I'm really not referring to Amazon's free RTOS, I'm saying open source RTOS stack. So taking this code into any other open source software RTOS stack is not a difficult thing, because Apache doesn't give you any restrictions in moving this code piece into another place. We won't have that legal challenges.
Okay, and with that, I would love to close it down here for the session. So we have 17 minutes for a break. Everybody enjoy that, and then please join us back. We have 3 more sessions coming up, and then the day is over. Okay, have a good break, everyone.
Thank you.
Thanks, Khasim.